Welcome to the last part of the Girder stressing video. In this video, we will learn how to perform the stressing work at site and the calculation is done. First, the equipment assemblies. Let's assemble the stressing equipment with the girder at field level. After installing the strand, first insert the anchor head, insert the wedges, place the limiting plate, set up the hydraulic jack, connect the hydraulic pump to the jack, install the master plate, finally install the master grip. The same stressing arrangement will be done at both ends of the girder. After completing this arrangement, we will start the stressing work. For the design requirement, first we will apply 50% stress on cable 1, then 100% stress on cable 2, again 100% stress on cable 1, finally 100% stress on cable 3. During the stressing, we will record the elongation data corresponding to the pressure calculated earlier as shown in our previous video. The pressure will be applied simultaneously on both ends, and the elongation data will be recorded at the same time.
This setup features a hydraulic pump equipped with a pressure gauge that measures the pressure in MPa. This is the piston of hydraulic jack that extends outward when the applied pressure is transmitted to the hydraulic jack. The piston's movement represents the elongation of strand, which is measured using a scale and analyzed for stressing. So we will give pressure 5, 10, 20 and 25 MPa in the hydraulic jack and record the corresponding elongation of strand.
Before starting the stressing work, we will fill out the record sheet. Here the length of girder is 42.68 meter and the corresponding design elongation is 304 mm. However, the grip length or jack width extends 400 mm from the face of the girder. So additional elongation required, that's PL by AE. Here P equal to 3645 kN, L equal to 400 mm, A equal to area of steel, that is 19 into 140, and E equal to 198 gigapascal, that is 3 mm for one side.
So for 10% force of 5 MPa pressure, elongation found one side 19 and another side 22 mm. Again for 20% force of 10 MPa pressure, elongation is found to be 33 mm and 37 mm. Next, the remaining forces are given and the data were recorded.
The elongation recorded at one end are 19 mm, 33 mm, 70 mm and 86 mm, and the other end are 22, 37, 70 and 85 mm respectively. Therefore, we will exclude the first data point for zero correction in our calculation. This correction process will be explained briefly during the calculation for cable number 2. The next column difference of elongation and the last column cumulative elongation that will be calculated. Now we will apply load to cable number 2. For this, we will shift all the equipment arrangement to cable number 2. We will apply the load in stages of 20%, 40%, 60%, 80%, 90% and 95%. After applying each load stages, we will observe the corresponding elongation and calculate the elongation difference and the cumulative elongation for both ends as per the record format. The reading found
for 20% stress, elongation is found 42 one side and another side 39. For 40% stress, that is 76 and 73. For 60%, it is 109 and 106. For 80%, it is 140 and 140. For 90%, 156 and 155. For 95% stress is 166 and 165.
Initially, we will complete the calculation same as before. First, the elongation difference and second, the cumulative elongation. To predict the present elongation status, we need to find out the zero correction. Now, what is zero correction? Zero correction is adjusting the initial reading of the jack or the gauge before starting the stress. When the cables are initially laid in the duct, they remain in the relaxed state. After applying force, they straighten and some elongation occurs before the force is fully transmitted to the cable. Actually, this elongation is not due to the applied force on the cable itself, but rather due to the cable straighten and taking up any slack or gap. So how can we find the zero correction? We can find this in two ways. The method 1, average the first 3 data points. Ensure equal loading intervals. Here the loading intervals are 20 for 3 items. The values are found 33 and 34 mm. Method 2. Plot a graph of gauge reading and the cumulative elongation. The x-axis intercept gives a zero correction value. This is the zero correction value. Here also found the value 33 and 34 mm. Now we will see the present elongation status. We will add the cumulative elongation data from the both ends and then add the zero correction, and finally subtract the slip and the grip elongation. Typically for 42 meter girder, the slip is considered at 10 mm and the grip elongation is 3 mm. In this case, the calculated elongation is found 291 mm, which is slightly less than the required 302 mm. Now we will apply stress up to 100% and the measured elongation is 304 mm, which is greater than the required 302 mm. Therefore, we can stop the stressing operation. We will slowly release the stress. After releasing, the final elongation value was found to be 164 mm and 162 mm, resulting in a slip value of 9 mm each. Now let's complete the calculation. Cumulative elongation equal to 131 mm plus 33 mm equal to 164 mm. Net elongation equal to cumulative elongation minus slip minus grip elongation equal to 152 mm. After that, we will mark the tendon at a specific distance and check the slip reading after 24 hours. Typically, the change is between 1 to 2 mm. We will repeat the same process on the other side. Finally, the total elongation was calculated 305 mm.
Now we will give the 100% stress of the first cable. In this case, we will give a stress 10% to 100%. For 10% stress, the elongation is found 7 mm and 5 mm. For 20% stress, elongation is found 9 mm and 7 mm. Next, the remaining forces are given and the data were recorded. After completing this data, we will check the current elongation status. Now we will prepare 3 graphs from this data. The first graph is the first stress percent force versus cumulative elongation data. From this graph, we will calculate the zero correction. The second graph, second stress percent force to 50% loading versus cumulative elongation data. The third graph, 60% to 100% force versus cumulative elongation data. The second and third graph intersect each other at a point. The deviation is determined by drawing a horizontal line through the intersection point and extend it to intersect the first graph. Now make the lines by putting the values in the table and complete the graph. This point is 68, this point is 11, and this point is minus 21. So the value is 68 minus 11 plus 21, that is 78 millimeter. In the same way, the other side calculation is completed and the correction is found 70 millimeter. Thus two corrections are 78 and 70 millimeter. After applying the correction, the present status of elongation is found 299 millimeter, which is 5 millimeter less than the targeted elongation of 304 millimeter. Therefore, an additional 7 millimeter elongation is allowed, the 3 millimeter on the left side and 4 millimeter on the right side. The corresponding gauge reading are 49.5 MPa and 50 MPa, that is 101 and 102% of force. Before locking, the elongation was 97. After releasing pressure, the elongation was 87 millimeter, giving a slip of 10 millimeter. The right side slip was found to be 9 millimeter. So the cumulative elongation equal to second stage cumulative elongation plus correction, that is 90 plus 78, that is 168 millimeter. Net elongation equal to 168 minus slip minus creep elongation, that is 155 millimeter, and the same way 152 millimeter for the right side. After 24 hours, slip was found to be 0 at both ends and the total elongation is calculated 307 millimeter. Following the same procedure of cable number 2, the elongation is found for cable number 3 is 305 millimeter. Finally, the hogging of the girder at the middle portion was measured 27 millimeter. After 24 hours, the hogging was rechecked and re-recorded. Thanks for watching. If you need the Excel sheet, collect it from the description below. Thank you.